Okay, let's dive right into this explainer. July 18th. It's kind of wild when you stop and think about it, but this single date is literally one of the greatest dates in all of math history. Seriously, on this one specific day, across totally different centuries and countries, brilliant minds were either born or passed away, and they completely changed the world we live in today. Let's meet them, one by one.
To kick things off, think about this for a second. Why do bungee cords, or even just the suspension in your car, why do they bounce perfectly, instead of, just snapping in half? Or why does a trampoline safely throw you right back up into the air?
Well, to find out, we actually have to rewind all the way back to the 17th century, specifically to a guy named Robert Hooke. And guess when he was born? Yep, July 18th, 1635.
So what Hooke did was pretty game-changing. He figured out the exact math behind how materials stretch out and then spring right back into place. Today, we call it Hooke's law of elasticity. The basic rule? As is the extension, so is the force. In plain English, that just means the harder you pull on a spring, the harder it's going to pull back with an equal, totally predictable force. It sounds super simple now, right? But that one mathematical idea is exactly what powers so much of the modern engineering and shock absorbers we literally trust our lives with every day.
And that brings us to our first big takeaway. Every bounce, every shock absorber in our physical world is hiding a simple mathematical spring inside it. Math is literally acting like the glue, or I guess the spring, holding our physical world together.
Okay, so moving right along, but staying on July 18th. Let's fast forward a bit and see how this builds. Have you ever stopped to wonder how engineers manage to measure perfectly precise circles? I mean, the kind of absolute precision needed to keep our modern GPS satellites orbiting exactly where they're supposed to be in space?
The foundation for that kind of mind-blowing precision traces back to a man who, believe it or not, died on this exact date, July 18th in 1742. His name was Abraham Sharp.
Now, Sharp was a guy who took dedication to a whole new level. Long before computers were even a sci-fi dream, Sharp sat down and calculated the value of pi by hand to 72 decimal places. In 1699, he was also the guy engraving the absolute most accurate astronomical instruments in all of Europe. He was carving these incredibly tiny scales and numbers purely by hand. And that fierce dedication to absolute perfect measurement, that completely paved the way for the digital precision you and I take for granted now.
Just let that sink in for a minute. The ultra-precise numbers that literally build our modern world, they started centuries ago with hand-carved instruments. What an absolutely incredible legacy to leave behind for us.
All right, same golden date, July 18th, but now we're jumping to 1891. Different country, completely different, but massive idea. So here's a question for you. How in the world do our weather apps predict those extreme, once-in-a-century floods, or those massive, super rare storms?
The answer leads us straight to Emil Gumbel. And you guessed it, he was born on July 18th, 1891. He was just this incredibly brilliant, dedicated mathematician.
Gumbel created something known as the statistics of extremes. So instead of just looking at average, everyday, boring numbers, he decided to look for mathematical patterns in pure, unadulterated chaos. His math is what actually allows us to calculate the probability of really rare, severe events. Because of his work, engineers know exactly how high to build a dam to keep a town safe, and meteorologists know how to properly forecast those terrifying extreme weather events today.
Which leaves us with this really profound realization. Every extreme disaster has a hidden mathematical heartbeat. Even in the absolute worst, most chaotic storms, there is a pattern there. A pattern that we can actually measure and prepare for. One date, so many wild stories. Let's keep going. Take a second and think about the smartphone sitting right there in your pocket. How does that tiny device know the absolute fastest way to solve a really complex problem, or route your internet search literally instantly?
The answer takes us to our final mathematician for today, Edwin Beckenbach, who was born on, you know it, July 18th, 1906.
Beckenbach's absolute mastery was in a field called the mathematics of inequalities. Now, this isn't just about things being unequal. It's really about finding the absolute best or most optimized way to do something out of a ton of different options. He actually helped create SWAC, that's SWAC, which was one of the world's very first supercomputers over at UCLA. His foundational work essentially helped launch the computing revolution and optimize all that digital problem solving we rely on every single day. It's kind of mind-blowing to wrap your head around, but
The pocket supercomputers we carry everywhere today were literally born from the mathematics of inequalities. It's just incredible how these early, abstract mathematical rules are what make our modern lives so incredibly fast and connected.
Section 1. What connects them all? A common thread.
So, as we wrap up our explainer today, when we map it all out on a timeline, we see this one single date, July 18th, spanning centuries of continuous human innovation. You have Robert Hooke, born in 1635, Abraham Sharp passing away in 1742, Emil Gumbel, born in 1891, and Edwin Beckenbach, born in 1906.
Every single person we met today, coming from totally different centuries and different countries, they all essentially asked the exact same question. What is the pattern hiding inside the chaos? And it's exactly because they dedicated their lives to searching for those patterns that our world today has GPS, incredible engineering, advanced weather prediction, and the internet. So it kind of leaves you wondering, what patterns will you look for today?